Welcome to this e-learning presentation from Vicom. In this user training presentation, we're going to look at operating the DMA MPS 43 air data test set.
Welcome to this introduction to the DMA Air Data Test Set type MPS 43. Now, any of you who've been involved in air data testing for a while will realise that this is something of a revolution in terms of its size and weight. We've been looking for something like this for many years. This is a fully automatic test set. You are able to call for altitudes, airspeeds, rates of climb, Mach, all the usual capabilities, and it will deliver them to you for the aircraft or the unit under test. It only weighs about 10 pounds or 4 kilograms, and size-wise you can see it's absolutely ideal in terms of being able to take it around with you, carry it out to the aircraft, or even travel with it. It comes complete with a carrying case. The carrying case in turn has inside there all the manuals that you need, and there are 4 manuals. One is the operating manual. Then we have the calibration and adjustment manual. Then we have the Adwin software for you to load onto your PC, because this instrument is capable of being driven by a PC, as we will demonstrate shortly. It comes complete with the AC power cord, of course, and we'll talk about the power soon. It comes complete with the coloured hoses, red for the altitude stroke static and blue for the airspeed stroke pitot total. It comes also with the lead to enable you to control it from your PC, which is an RS-232 link into your PC. And it also comes with the CD disk for loading your computer with what we call our Adwin Air Data Windows software. We'll get on now and start to show you the details of this test set in terms of the front panel components, and then move on from there to show you how the instrument operates. Right, well, I'll probably be a disembodied voice over to the side while we go ahead and describe the components on the front panel of the instrument. Now we've taken the lid off. The lid is capable of being removed so that it's not in the way while you're using the equipment. Right, let's just go through. There are 1 or 2 little differences on this front panel. This is a demonstration instrument, perhaps different to the one that you're using, but they're fairly insignificant. The power switch. This is where we turn on the AC, and this is where the AC power comes into the instrument. It can accept any power between 90 to 260 volts AC, and any frequency from 48 to 440 Hertz, 50 watts maximum load. This means that the instrument is capable of running on any AC supply in the world that we can think of, and in addition, aircraft 115 volts. Additionally, the instrument has battery power as backup. The battery power is there for emergencies. It's there in case you lose the AC sometime during the testing, either because of a local outage or one of your friends decides he wants your AC outlet more than you do. It does happen. So we've got about 30 to 40 minutes backup power. We do not recommend the instrument to be run as a battery powered instrument. It is there for backup, and we'll demonstrate that later. Okay, moving around the thing now. We have an external port here which is RS-232, and this enables you to have a lead through from here to your PC, and you can then drive the instrument from the PC, and you can use your PC to take all results from any test that you carry out. More of that in a little while. Coming down to the ports. The ports are for the static and the pitot. The static is an AN4 size and the pitot is an AN3. The connections are only finger tight, so you would get, for example, the red connection for the static here, and you only need to just tighten them with your fingers. You do not need a wrench. It's not necessary. There's an O-ring seal on the fitting. We come then to these two letdown ports. They are there purely for an emergency. With the battery backup capability of this instrument, it's unlikely that you'll use these ever or very infrequently, because you will get a warning when the battery is running out, and the battery would then enable you to bring the instrument down from your 25,000 feet, 300 knots, whatever, safely to ground. But if for some reason the battery is exhausted and you're still at those values, you have the ability to gently open these valves and let Mother Nature bring the entire system down to ground level. Going back to the power just for a moment before I forget all about it, we have here a grounding point. Even though we have a ground core to the AC power cord, in addition, just in case it's not live at the other end or connected at the other end, you have a point where you can tie the instrument to the same ground as the aircraft. We don't want any sparks. There is then the fuse, just in case you should need it. As you see, it's fused at 2 amps. Coming down now to the business end, if you wish. This is the business of the display and the keyboard. Now this is something of a dual use. Not only is the display giving you what is happening, but it's actually a touch screen in addition, so that you can either use the keypad, we'll demonstrate in a moment or two, or you can use the touch screen. You're able to use either, whichever you feel more comfortable with. That's pretty much a description of what the instrument contains. What we're going to do now is to go through a complete startup procedure so that you can see exactly what happens, and we'll zoom in now so that you see directly the screen and the keypad. Okay, now we'll power the instrument on and talk you through the startup screen. When we turn on, the instrument comes up with the DMA logo. It shows you MPS 43 and its serial number, the revision of the software, and how many operating hours the instrument has done. Then automatically the instrument goes into the vent mode to bring you down to the ambient conditions, so that before you start your test, you are down at ground level and you know exactly where you are. So it will take a few moments where the instrument just comes down to what it has measured as the ground pressure. Internally inside the instrument, it reads the ground ambient pressure. And there is a valve on the box which makes sure that you are reading ground, not some in-between value. You can see the instrument then comes up saying venting ended, ambient pressure reached. You're now at a nice datum point, you know where you're going to start. We can get rid of this screen by touching it or pressing the enter key. This is the first example of being able to use either the keys or the screen. So if I press the instrument, there we are. Now let's talk you around the screen. We have effectively 4 parameters on display. First of all, we have altitude in feet. We have rate of climb in feet per minute. We have airspeed in knots, and we have rate of airspeed in knots per minute. You don't have to have the displays in aeronautical units as you have here. You can work in pressure units if you wish. And you see we have a key here in the bottom corner. If we press this, we can change from aeronautical units to engineering units. I press, and now we're showing pitot static instead of altitude, and we're showing QC instead of airspeed. We're showing it in hectopascals, the international SI units for pressure. If, however, you are a user that still uses more imperial units or something different again, you have the ability to change. This key here, the units key, or the same under yellow, because you can press either, enables you to change the units. If I press this, it says, okay, which pressure units do you want? And you can drive around the screen. You can drive around with this key here, or you can actually go directly in and say, I want inches of mercury, and instantly you're now working in inches of mercury. Additionally, we're looking at the QC value, which of course is the pitot total value minus the pitot static, the differential pressure. If you want to work in two absolute units, you can by this key here, which says QC or PT. If I press PT, now we have PS and PT, both as absolute units. Or press it again and go back to the QC. And go back, if we wish, to the engineering units. Okay, so we've described how the instrument starts up. It starts up in that vented mode, so we're starting from a good known position. And we can now go to the business of entering demand values. Because underneath each of the simulated values, it's altitude 23 feet, and at the moment it says 30 is the demanded value. It's moving away because of the hot lights here in the studio. I can now say I want to go to my first point. There is a bracket around the altitude, meaning that we are talking to this particular parameter at the moment. If I want to talk to airspeed, I can touch the screen, and now I'm looking at airspeed if I wish. Or I can use this side arrow here, and this enables me to actually step around the screen. So I'm back to altitude, and then I would go to rate, and then I'd go to airspeed, and so on. So at altitude, if I say let's go to 3,000 feet as a demand value and press enter, it will now begin to go to 3,000 feet at a rate of 3,000 feet per minute. We can change that if we wish. Maybe we will in a little while. At the same time, I can ratchet round again to the 3,000 or to the airspeed and say, now please go to, let's say 50 knots. Enter. We must always enter to confirm that that is the value that we require. And the instrument will now take us to those values at the rates demanded. It's 300 knots per minute as standard and 3,000 feet per minute as standard, but you can change them all as you wish. The default values are these two, because we reckon these are relatively safe for most aircraft. When we get close to the 3,000, you'll find that it will change from the rate that we've called for and slow down and down and down so that we do not overshoot. When we get close, but it won't start to come down until we're relatively close. You see, it's coming down now as we get within striking distance of the demanded 3,000 feet. There we are, 2, 9, 9, 6, 7, 8, 9, 3,000. That's what we've asked for, and that's what we get. So you can see it's relatively easy for you to call for the demanded values that you want for your test. Now in real life, if we were connected to a unit under test via our ports, then you could probably decide that it was sensible to carry out a leak test to make sure that your hoses and your adapters are all tight and you're not going to be any leaking situation. Well, we have a test. We have a key for a leak test. When I press that leak test key, it immediately shuts off the control and shows altitude leak in feet from the moment we started and the rate that it's calculated in feet per minute. And down here we have the time running. It's 17, 18, 19 seconds since we pressed the button. And it shows the altitude leak and the airspeed leak, the rate of altitude and the rate of knots. That's fine. You could, for example, keep your eye on that particular time and wait for the appropriate time to see whether it's within specification for the leak test on your aircraft. However, this means you've got to stay and keep your eye on that figure. If you'd like to go off and do another test, then you can go to the time situation. if we press the time key, it gives you the ability to time for a certain length of time. We've got 1 minute here, we could change it if we wish. But if I now say, okay, let's go, it's now started the clock running from 60 seconds, and at the end of that 1 minute, it will then lock onto the screen the actual leak over that 1 minute period, or 5 minute period, or whatever time it is that you use within your organisation for doing your leak test. The good thing about running the clock like this is that while it's happening, you can go away and go and do some other task while on the aircraft, or if you're really desperate, you can go away and have a cup of coffee. And at the end of the time, you can come back and it will still be here waiting for you on the screen, so that you can decide which way you prefer to go. Okay, we're coming now to the end. We're within 10 seconds of the desired time, and at the moment it's saying we've got a leak of 24, 25, here we are, 2, 1, 0. So there we are, and it gives us then the answer. It says altitude, it's now at 29.67, sorry, 2967 feet, and it's a minus 27 feet drop. And airspeed, there's a 1.2. Those are real figures. They are, however, vastly exaggerated in terms of the real world, because we're testing into a blank end. We've not got this instrument connected up to an aircraft or to any significant unit under test. It has to be remembered that when you work like this, you've actually got yourself, in effect, a gas-filled thermometer. As we've locked that pressure into the instrument and the temperature rises, it will show an exaggerated leak. If you're normally connected to an aircraft, you'll find that that leak is down at whatever. If the aircraft is tight, you'll probably be looking at something like 5 or 10 feet per minute, worst case. While we're just mentioning this, the static is designed to work into 1.5 litres, which is about 90 cubic inches, and the pitot is designed to work into 1 litre, which is about 60 cubic inches. The instrument is perfectly happy working into larger volumes than that, but you wouldn't necessarily be able to achieve our specified 6,000 feet per minute into a larger volume than 1.5 litres, 90 cubic inches. Okay, when we finished our leak test, okay, we can come out of there and we can go on and look at some of the other things that we can do. At the moment, it's dropped down, of course, from the 3,000 feet that we asked for and the 50 knots. We can now go in and go to different values. We could, for example, go and say, okay, I want 4,000 feet. And I can enter in, oh, correction, I'm still looking at the airspeed, so it's doing a crazy. If I was to try and put 4,000 feet into there like that, but I was on the airspeed and press enter, it won't let me have it. It would only let me have 550 feet. And that's because the instrument has got limits. And the limits are such that if you call for something in error, like I just did, then it won't let you go to crazy values. It protects you and the unit under test. It's let me go to 550 feet because that is the maximum speed that the limits are set to at the moment. We'll talk about that in a moment. So we'll cancel that. We'll go up to altitude. There we are. Altitude, go to 4,000 feet and press enter. It's there, but it's not going. If I go now to airspeed and go a sensible value like 150 knots, enter, it's still not going anywhere until I now press control. Now it will go to the values that we've asked for. It's a useful feature, the measure and control. If I was in the control mode and I put in 10,000 feet, it will immediately begin to go to 10,000 feet. If, however, I'm in the measure mode, as we were just a moment ago, I can put 10,000 feet in, it won't go anywhere. I could then go to airspeed and put in a value, 300 knots, and enter, and it will not go anywhere. When you then press control, the two will begin simultaneously. So it can be a useful feature in terms of actually moving at a desired rate from a desired start point. I think we've demonstrated while this has been happening that you have the ability to either use the screen to touch it, or you use the keys, whichever you prefer. Some people prefer a touch screen, others prefer keys. So we built the instrument so that you can use whichever. At the moment, if I ratchet around so that the brackets are around the altitude again, we call for 4,000 feet, and we're at 4,000 feet. If you would like to increment up in fixed amounts, the up and the down key here enable you, if I press up, it adds 100 feet. Do it again, another 100 feet, and so on. So this can be quite useful if you just want to test a few test points incrementally, all the same. Obviously the down key does the same sort of thing. And this works on all the different parameters, whether it's altitude, rate of climb, airspeed, or whatever, whichever you prefer. So those are the relatively straightforward parameter changes. Other things that we've got are hidden via the shift key, and then there are background operations which can be carried out. For a very simple one, we have shift and LCD. You can change the brightness of the display. Others we're going to investigate later is shift and remote, so that we can enable the test set to be driven by a PC remotely. You also have features like shift and true airspeed or indicated airspeed. This instrument as standard is showing you indicated airspeed. If we press shift and true airspeed, then you can have true airspeed, but in which case you will have a situation where you need to enter the temperature in the surroundings of the probe so that the instrument can calculate true airspeed. To come back, you do the opposite. Fairly straightforward in that respect. The one that's interesting in terms of many capabilities is the shift and menu. Now under the menu, we then get access to a number of capabilities. We've already talked about the one which is highlighted at the moment, which is limits. Now I can touch limits or I can press enter. And here we are, it displays the limits which are fixed into this instrument at the moment. So for example, we have the minimum altitude is set at minus 2,000 feet. The altitude maximum is set at 55,000 feet. The altitude rate maximum is set at 6,000 feet. The airspeed maximum, as we've already seen, was set at 550 knots. An airspeed rate max at 300 knots. And there we are. And we could go along and change those if we wish, and then press save. If we press save, those will then be the new limits for the instrument. It's important to understand that that's therefore held in a volatile memory, which means that if you then switch off the instrument, you'll have the situation where it will revert to the standard factory fittings, in other words, the ones we're looking at the moment. If you want to change it permanently, so that this instrument used in your organisation never must go over whatever limits, you can go in there and change them permanently. But you can only do it under what's called, if I go to shift and menu again, there is this settings. If I press settings, it would tell me to enter a PIN number. In other words, it is protected from anybody going in there and changing any values, and they're not authorised to change it. Unless they've got the PIN number, they will not be able to get in. Similarly, under the maintenance. Under maintenance, you cannot get in unless you have the PIN number. The PIN numbers are all included in the manual that we showed earlier, which is the calibration and adjustment manual. In there, it tells you how to do all of these things. Okay, so we've done that. We're still operating. By the way, we've reached 150 knots and 4,000 feet. We can, of course, then use the measure, go out of control into the measure mode. And what that does for you, it gives you added precision. Because although our control system in here is what we would call first class, and we hope you would too, it does, of course, have an influence on the value trapped within the system. When you go to the measure mode, you're removing any external influences. You're getting a very, very accurate answer of what the system is currently at that moment. You have, in fact, a very expensive pressure gauge, if you wish, but that's a byproduct of the whole. Okay, let's go back to the shift and the menu, because there's another very significant key is the functions key. Under functions key, we have the ability for Mac. If we go to the Mac key and we press that, you'll see that what's happened is instead of showing airspeed in knots, it's now showing in Mach. Okay, and that will be calculated depending upon the altitude that you are at that moment. If you change the altitude, then the Mach needs to be re-requested. Okay, when we say end, we come out and go back to knots. Shift and menu again to functions. We've talked about Mach. EPR, engine pressure ratio. Again, as a byproduct of an air data test set, you can use this instrument for doing engine pressure ratio transmitter testing of gas turbine engines. What happens is that the static port is redesignated as the inlet to the jet engine, and the pitot port, or QC, is designated as the exhaust, and you can then enter in what ratio you would like to set up versus the static pressure, and it will set you up at that particular engine pressure ratio. You have to think of it as a byproduct of pitot-static testing, but it's a very useful one if you've aircraft that you need to test. The next one then is altitude offset. Altitude offset, that's all about, we are measuring here inside this instrument with very precise sensors the pressure within the instrument at this point. Now, if you are using this instrument, for example, in the flight deck of the aircraft or even down on the tarmac, it's probable that your air data computer sensors, where the aircraft is measuring the pressure, is some distance away. It might be 3 or 4 or 5 feet. It could even be as much as 20 feet. Now, you've spent a lot of money buying an instrument which is accurate to within the RVSM requirements, reduced vertical separation minima. If you don't account for the altitude offset, you are to a degree throwing away the accuracy that you've spent a lot of money on. So you can go into there and enter in the value. If it's above you, then it's a positive value you put in. If it's below you, it's a negative value. Quite straightforward. True airspeed or indicated airspeed, you know that's also a shift number 5 key as well, because it is something that gets used quite regularly, so you don't necessarily have to go into the menu. It's there though if you want it. Ultra low speed. If you're going to use this instrument, for example, testing helicopters, where you're probably going to be interested in quite good accuracy at very low airspeed, and by that I mean down below 50, 60, 70 knots, then you can go into the ultra low speed mode. What that does then is to carry out a zeroing of the QC value here to make sure that you actually get a very good precision on your very low airspeed. It's not something that you need for any other reason, but it is there should it be needed. Finally, we have profiles. Now, the profiles is an interesting one. The instrument has the ability, inside here, to store up to 30 different profiles or test routines, if you wish. These test routines each can comprise, if you wish, as many as 26 individual test points. We remember 26 because we use the alphabet also. So we point A, point B, point C, etc. If we go to profiles, you have the ability to edit them, to bring up a new test, or to run it and carry out the test, or you have the ability then to look at the results. If I go to edit as an example, you can see we have a variety of different ones here. Test number 1, test number 2, test number 3, and so on. I can go down through them, or I can even press the down arrow on the screen, whichever we want. We have a test here which I've just put together, which is a simple test of 4 points. 4 steps. It's test number 4 as it happens, and there are 4 points, and I've given it the name John, my own name. Okay, if I want to run that test, I press select, and it says the name of the test is John, and it could be anything. It could be Boeing 747 whatever. The units that I'm working in, aeronautical, because I could work in something else, or steps, and so on. Okay, that's the actual unit. If I press save, we've saved it, it's in there. Go back. Do you want to save it? Yes, I do. Profile saved, so it's there. If I'd changed it and called it Bill instead of John, fair enough. Okay, then I can run that test if I wish. If I press the run key, it says, well, which test do you want to run? So you can go through and step through which one is it to be, and it's going to be test John. If I press now select, it's now going to run that simple test. And the simple test is we're on step 1 of 4, and the first point is please take it to an altitude of 0 and take it to an airspeed of 50 knots. You can change all these. You can build into the test routines, the profiles, the ability to actually build in a leak test, for example, so you can do a stabilization time. You have the ability, in addition, to build in a sufficient pause time to enable the operator to read the value of the instruments under test. And we give you the ability in here to set up as many as 3 different instruments for the cockpit. So you have captain, first officer, and auxiliary. And when you've set your test to go to the first point, let's say it was 50 knots, you could then go in, interrogate the individual points, and enter in any difference that there might be. So here we are, it says unit number 1, etc., etc., and I say OK. It's because this is just a demonstration, I'm not going to bother entering values in, but it says some readings are outside tolerance. We could accept that or say no, we must do something about it. I say yes. So we go now on to point number 2. I'm going to now 500 knots as my second point, and 500 feet and 100 knots. And so we go all the way through. It takes us a few moments, but it's worthwhile enabling you to see just what happens the test can be, as you can see, quite complicated. I will just step through the same as before. We're now on to step number 3, going to 1,000 knots and 1,000 feet and 150 knots, and we're stepping through each of them. What you can do with this is to build in an automatic leak test, so that, for example, if you always have a routine within your organization that says before we begin a test, we will always carry out a leak test, and it will always be at 25,000 feet, 350 knots, whatever, you have the ability to actually write yourself a small program like this, call it factory leak test or whatever, and what it will do then is enable you to have it fixed. You guys on the flight line perhaps don't have to try and remember what it is, it's there. They just go to profile number X and carry out that leak test. It's quite a useful feature. We're on the last one now. We're going back to an altitude of 25 feet and an airspeed of 25 knots as our last value. What we'll do then is we'll have a look at the results, because you can then interrogate the results. We've not mentioned earlier, and we should have done, as you get closer to the actual value, it enters into a stabilization mode where it allows things to settle so that you come to the value and you are at the desired values. Okay, so this is step number 4 and so on. So again, I will just ratchet through as before just to say we've finished. Do you want to save the results? We'll say yes, why not? Okay. Okay, so we've done it. Which one we want to save? Test number 4, select. There we are. Select, that's it. Confirm overwriting the results of John from a previous demo that I've done, say yes. Results saved. So there they are. This is a very simple test. So for example, if I say yes, we're happy with that, what I could do now is go to the menu again, go to the functions and go to profiles and actually look at the results. And the results, I say which one do we want to look at. We can go up and down with the key here or on the keyboard, whichever you prefer. That's the one we want, select, and here we are. And it enables me then to see the results for the altitude and the airspeed for unit number 1, for example, the captain, unit number 2, the first officer, unit number 3, for example, the standby. While you've just got a few points like that, looking on this screen is fine. But if it was a long test, maybe you'd used all 26 points for each one, whatever, then it might be that you prefer to take those results and put them into a PC. And we're going to demonstrate that in a moment to show you how the remote control works. But basically, we're happy, back. We're finished, cancel. So that's kind of described pretty much all of the capabilities of the instrument, I think. It's a case of, have I been around all the the keys and what have you? I think we probably have. At the end of the test, just as at the beginning of the test, you probably go to the vent. You'd want to bring this aircraft down to ground level. This is something that you'd always have uppermost in your mind if you'd lost the AC. And I'm going to actually now just disconnect the AC just to prove to you that we have got the situation where you see what's on the screen, and now we have the dreadful situation where we've no AC. Doesn't matter. The instrument is going to be perfectly in order for something in the order of 35 minutes. We can then reconnect, assuming that the AC outlet is available to us. Otherwise, you'd use your DC and you'd use the ability now to bring the aircraft down to ground in an automatic mode rather than having to do it manually. Remember, you can if you wish. If you've got to do it manually, you'd open up the 2 needle valves gently and you'd let it come down to ground gently. And at the end of the exercise, please, you would close those valves gently. You don't want to screw them so hard that you ruin the seats. So there we are. So now, to come down to ground level, you can see that it's the uppercase of the leak key. We press Shift and Vent, and automatically the instrument knows what the ambient temperature is. It's measured it internally, and it will bring the instrument now down to that safe value. This is always the point where you would like to leave it. You're making sure now that the pressure inside the instrument is exactly the same as the pressure in all the hoses and the adapters and the aircraft, so that as we then disconnect, there is no violent jump which might do damage to the older fashioned instruments perhaps. With solid state instruments, it's not a problem. And it tells us venting ended, we are now nice and safe. I think we've been around most of the things that need to be talked about. So we're going to have a little break for a moment while I now connect up the instrument to a PC just to demonstrate to you how the remote control operates. Okay, we've reorganized everything now. We brought the laptop alongside the instrument. We've connected up the interface RS-232 cable. The standard cable comes complete with the RS2 connector. Many modern PCs don't necessarily have this connector. You may need to buy yourself an adapter to the standard USB port, which is what we have here. We then went into the instrument, and by pressing the Shift and the 4 key, we put it into the remote mode. And here on the screen you see it now says remote, and it shows a C alongside, just say it's external. Now, on the screen I'm running the AdWin software, of which we supply you with a full manual, which is very complex, very all-capable software routine. I'm only going to show you the very minimum, just to show that everything works okay. It brings up this screen, not dissimilar to what you've been looking at on the instrument itself, and we can then drive this in the way that we want. So for example, I can go to the command screen for altitude. At the moment it's at 2,000 feet. I can change it to say please go to 5, whoops, missed, go back, 5,000 feet, and then go to go, and automatically that is now the demand value, and we go from the 2,000 feet we were originally, and we go to 5,000 feet. And it's the same if we want to go to change the airspeed. We can say please go to 300 knots and go to go, and off we go. And there we are. We've just simply proved to you that we are able to control the unit from a PC if you wish, which does give you the ability to do very complex results, storage and manipulation of the data on, for example, Excel or whatever. And you have all the other capabilities that you would normally have, including going to leak. And we can now take the instrument down to ambient. And that's exactly what's happening, as you see on the display. So there we are. I think we've now covered pretty much everything you need. I hope it's been useful to you, and I hope it's covered the majority of the points that perhaps you had some concerns about in terms of interpretation. Thank you for your attention. I hope it's been useful. Goodbye.
Well, that's it for this presentation. If you have any questions or need help, please contact us. You'll find our details on Vicom's website.